Richard has got a huge memory for poems and is great at reading poetry, and sometimes he speaks poetically. In fact, one of his speeches was used as the lyrics for a song by our musical director. I'm just going to play you a very short clip of it now. Ladies and gentlemen, Dawkins and Krauss.
Well, we've done a lot of double acts together, Lawrence, but this is the first time I've had the pleasure of interviewing you.
Yes, I
and
can't
I'm
wait.
going to treat it, with everybody's permission, as a kind of tutorial in physics.
Okay.
Because I hardly understood a word of what you said.
Which is always my test case.
For example, I mean, when you said, this is ridiculous, this is absurd, and therefore everything's absurd in modern physics, isn't it? in the same sense. I mean,
yeah, you're right in the sense that you're absolutely right. Modern physics has taught almost everything is absurd when it comes to conventional wisdom and common sense. It's taught us that common sense is not to be trusted.
You have to go to the actual data.
You have to go to the data and ask if common sense is consistent with the data, and you should be willing to accept. And I think, as you probably said, it's not surprising that common sense doesn't work, because common sense is evolutionarily based, and it's based on the things that got us successfully reproducing for 1 million years, and not on understanding the universe. And the biggest surprise is that it somehow has led to a species that can.
It's hugely surprising that it's led to a species that can. And sometimes I console myself with the thought you just said, that after all, we evolved to work out where the next meal is coming from, and where the next member of the opposite sex, and where the next waterhole, and where and so on. And so it's not surprising that we cannot grasp the idea that when a particle moves from one orbit to another, it doesn't pass through the intermediate stages when a particle goes through two slits at once, and so on. I love there's a cartoon in the New Yorker, you've probably seen it. It's in a veterinary waiting room, a vet's waiting room, and the nurse is there, and she's breaking some news to one of the people who's sitting there with another person with a dog with one of those lampshade things on, and she's saying to one man, "About your cat, Mr. Schrödinger, I have some good news and some bad news." Well, Schrödinger made up the cat fable as a demonstration of how ridiculous the interpretation of quantum theory is. That in his terms, the cat is neither alive nor dead until you open the box, and that's clearly absurd, and yet it's one of the accepted, reputable interpretations of quantum theory. Another one is the many worlds interpretation, where there are numerous billions of universes where the cat is alive and billions of universes where the cat is dead, which is, to my mind, slightly less absurd, actually. It's very uneconomical, but not totally absurd. Where do you stand on that? Or I suppose there's the third school of thought, which is Feynman, who says, just shut up and calculate.
Well, I side with Feynman to a great extent there. I don't come on the side of either. I think they're both misplaced. I do think you're right. If you had to pick one, the many worlds interpretation is more palatable or closer, a little bit closer to what actually is the case. but neither are the case. And in fact, quantum theory does not predict that the cat is both alive and dead. It predicts that an electron can be spinning this way and that way. But properly interpreted, quantum theory says the world is quantum mechanical, yet the world around us is classical. We aren't, you're in that chair, you're not in that chair and in the audience at the same time. An electron could be, but you're not. So something happens when the world becomes classical. And if quantum mechanics is correct, then it should explain how the world becomes classical. And one of my colleagues and professors first, and then colleague and then friend, who's now passed away, Sidney Coleman at Harvard, who was, interestingly enough, the smartest person in the department. At the time, the department had 5 Nobel laureates in it, but he was smarter than any of them, and also funnier. He pointed out that we get it exactly wrong. There should be no such discussion as the interpretation of quantum mechanics, because the world is quantum mechanical. So anytime you describe the real world in terms of some kludge, which is the classical world we experience, you're going to prove something that sounds nonsensical, like the many worlds interpretation. And in fact, what we should try and understand is the interpretation of classical mechanics. How is it that the world we see is the way it is when the real world is different? And he gave a great lecture, which I talk about in the new book, and I really recommend you looking at it. You can see it online, called Quantum Mechanics in Your Face. But one of the things I didn't mention in the book, which I think is lovely, is the realization. So quantum mechanics says many weird things should happen, but when we measure them, we measure something different. People often talk about it as the collapse of the wave function. There's no collapse of the wave function. It's just thinking about quantum mechanics correctly and measurement, you realize how a classical observer will always measure classical things. And the example he uses is from a Tom Stoppard play where Ludwig Wittgenstein is standing on a corner in Cambridge and he's thinking, and someone stops and says, "What are you thinking about?" He said, "Well, I'm thinking about the fact that people say, that the Earth orbit doesn't orbit the sun. It just the sun doesn't orbit the Earth orbits the sun. It just looks like the." And someone says, "Yeah," and he says, "Well, I'm thinking about what would it look like if it was the other way around?" Yeah. And of course, it would look exactly the same. And
yes.
And you, when you think about it, and he carefully shows that this classical kludge can result from a careful understanding of quantum mechanics. But people who get hung up on the many worlds or interpretations of quantum mechanics and write books about it to make themselves seem profound, it's totally misplaced in my view. It's like saying the interpretation of general relativity in terms of Newton. Well, the results of general relativity in terms of Newton are absurd. Light doesn't go in bend in Newtonian mechanics. But if you try to interpret general relativity in terms of Newton, you'd have to come up with these weird kludges. But no one does it. I don't know. Well, I know why they do it with quantum mechanics, because quantum mechanics is so strange that people, even at their heart, because in principle we all have seen curved pieces of paper and curved things. So even if curved three-dimensional spaces are beyond our ken, we're used to the ideas. But quantum mechanics is completely beyond our perception, our experience, and therefore is innately not understandable. As Feynman said, if you think you understand it, you don't understand it.
So it's not the case that you're perfectly safe playing Russian roulette, because even if you shoot yourself in another world, you go on.
I would say it's not, and I would say that since life is finite, then it doesn't really matter, does it? I mean, because even in the many, the important thing about the many worlds interpretation is some people think that somehow those other worlds, if they are the same as our world, you can't go between them. So you're dead if you shoot yourself in the head. It really doesn't matter what's happening.
Yes, I didn't really mean that seriously.
Yeah, but it's precisely that reason that quantum mechanics, with many complex electrons and photons, do strange things that we can measure in the laboratory, but only if we very carefully prepare them. We see quantum teleportation and entanglement and all this exotic stuff. But the reason people win Nobel Prizes for that is it's really hard to do the experiments, because the minute you stop shielding these very carefully prepared states and allow them to interact with the world around them, all those weird quantum mechanical correlations disappear. And so that the weirdness of quantum mechanics is invisible to us, and objects like you and Schrodinger's cat, the challenge is to explain why Schrodinger's cat isn't both alive and dead, and a proper understanding of measurement theory and quantum mechanics will tell you that it's a nice.
So do you wish you were an experimental physicist?
Now that I'm older, yes. When I was younger, well, see, theoretical physics seems sexier. The people you heard of, Einstein, Feynman, almost all of the great theorists, great physicists you heard about in most of the 20th century that I sort of idolized, or at least made me want to be a scientist, were all theorists. Sitting alone in a room discovering the universe, which is not how it happens at all. But in fact, it was only, and when I was an undergraduate, I actually did experimental physics, which is what convinced me I didn't want to be an experimental physicist. Okay. Not only that it was easy for me to destroy things. I nearly blinded myself with a laser once. But what really convinced me, and this is one of the reasons I hold them in such admiration, is that I worked for 6 months on a little thing to try and get one little part of an experiment to work. 6 months on that one little thing, and yeah, I finally got that one little thing to work. But I'm a very impatient person, and and the idea of spending 10 or 20 years on an experiment which might reveal absolutely nothing was something that didn't appeal to me. But now, I certainly, as I became a physicist, my appreciation of experiment dramatically increased. Actually, when I was a graduate student, I used to do mathematical physics when I started, very mathematical physics, and it was a friend of mine named Sheldon Glashow, who's a Nobel Prize-winning physicist, who one day looked at me and said, "There's formalism and there's physics, and you have to know how to tell the difference." And what he convinced me was, you always should ground yourself in observation. You should never be far away from what we can measure, or you're at risk of sort of intellectual masturbation, of sort of wandering off into a domain that has nothing to do with the real world. And that caused me to, almost all of my work, therefore, has in some ways been related to things we can measure. Not all of it, but much of it. And the other thing about experiment that I envy now is that when you build something, it's real. You have something there. You have something to show for your work afterwards. Whereas ideas are so much more ephemeral. And you can never really, ideas are often in the background anyway. Einstein developed general relativity. It was a triumph, but David Hilbert, the mathematician, was that close to developing it. I profiled what we wrote in 1995. There were other people thinking similar things. So you never kind of feel like, with an experiment, you've done something, you've demonstrated something, you've really tapped into nature. It's terrifying if you're if you're a theorist. It really is terrifying to think that some weird idea that you're writing down might actually describe the universe. Really
let me raise another of the things that came up in your previous talk, when you said, even when the prediction is fulfilled to the umpteenth decimal place, it's still not actually true. And I get that. But on the other hand, when you say in all science, Darwin's theory of natural selection is true. That's not just provisional.
Well, that's an interesting question.
Okay, maybe not quite that, but the fact that we are cousins to chimpanzees is simply true.
Yeah, okay. There are scientific facts that what we've measured is true. Okay? What we measured, you can't, unless the measurement is wrong, and you can always test it and retest it. But when you measure something, you're dropping a ball, it's going to fall down, not up. No matter what we learn about quantum gravity, you let the ball go. 1,000,000 years from now, it's not going to go up. It's always going to be described by Newton's laws because our measurements have shown that in general. But it's not. But the question is it true over all times and spaces? And you could say with evolution that evolution is true, but it's manifested in the long term, over long times. It doesn't necessarily describe accurately what's happening at every instant when a biological system is working.
No, that's true.
So that's what I mean. That's what I mean by universally true. And you know, it's the challenge of evolution. The reason people don't buy it is that you need to understand long times, and it's something hard for people to accept that something as complex as the eye or DNA or RNA could actually develop.
Yeah. Well, let me persist in my role as the unintelligent layman trying to. When you excuse me, we hear about Hubble showing that the universe is expanding, and then Lemaitre extrapolating backwards. I get that extrapolating backwards makes sense, but why to a point? Why not to a sphere, you know, the size of the Earth or the size of the solar system or something? Why a single point?
Well, because if you take the theory seriously, then that theory and many theories of physics are time reversal invariant. So if you can extrapolate forward, then you can always run the movie backwards. And if you take the theory to its logical conclusion, with gravity being attractive, if the universe is always expanding, then at some point, if you work backwards, it's always contracting. And the extrapolation of that is to a single point. But you're absolutely right that we have no right to extrapolate the theory back to a single point because of what I said earlier. We know general relativity breaks down as a theory. We know it describes the universe beautifully and galaxies beautifully, but we know, and this is a great gift, we know explicitly the scale at which general relativity stops making sense. It's called the Planck scale. We know, if quantum mechanics is true, that general relativity stops making sense at a very small scale. So you can't extrapolate back and do it with any confidence. It doesn't stop physicists from doing it. And many physicists do it, and we generally, when you should take all of those things with a grain of salt, whether it's Roger Penrose or anyone else.
If I sound naive, it's because I reckon I'm probably not alone. And
yeah, no, it's great, and I know we've had these discussions, but I also know that. Well, anyway,
if I don't understand, what's the difference between inflation and expansion?
Oh, that's a great question, and again, you're probably right that I threw out the term. So what Lemaitre showed, really, Lemaitre and since then, is that general relativity doesn't allow for a static configuration of matter. And the answer is the same as Newton. Newton doesn't allow a static configuration of matter because gravity is universally attractive. So if you put a bunch of mass points down in Newtonian gravity, they're always going to collapse together because they're always going to be attracted by gravity, okay? And more or less what Lemaitre showed is the same thing is true in general relativity. If you have normal matter and radiation, it's more or less universally attractive, and therefore the only way you could have a universe that's as old as ours, if you started out with a static universe, it would have already collapsed by now. So the only possibility is to start it out expanding, and then it'll slow down and maybe return back. If you throw a rock, it'll go.
I'm familiar with the idea that when the solar system condensed out of a ball, out of a lot of gas, gravity was attracted to little nuggets of matter that were forming, and they gradually grew and grew and grew by gravity, and they became planets.
Yeah.
And so that's gravity pulling things together and making in this case planets or rocks or that's easy to understand, but contraction to a single point of infinitesimal size is utterly different from that.
Oh, it is, except why don't we collapse right now? Why are we sitting in these chairs? Thankfully, that's a rhetorical question. I'm not going to make you answer. But the answer is because of electricity and magnetism. Happily, gravity is the weakest force in nature, which is why we can ignore it for every experiment we do on Earth. It's the electric and magnetic forces that are holding this table up, are stopping it from going down.
I get that. But
so that stops the Earth from collapsing to a point. But if they weren't there, if gravity is universally attractive, there should be nothing that would stop it from keep on collapsing. And the great...
But the sheer volume of matter that's there couldn't collapse to a point.
Well, in fact, that's not necessarily true because, in fact, as far as we know, electrons have no volume.
No, but protons and neutrons do.
But they're made of elementary particles called quarks, which in the canonical picture have no volume, and photons. So they would break up into their constituent particles if you crush them small enough.
Okay, so you've answered my question in a way that I find very surprising, but I'm rather glad of it. Because what you're saying is that all the matter in the universe, all the protons and neutrons, electrons you can neglect, could be collapsed into a point. And all you're doing is you're crushing them and removing the space between them.
Yeah, and I'm saying, you know, you don't have to go to that level of potential absurdity. We can go to a scale where we think we understand the laws of physics. And in fact, I wrote a book called Atom, where we can, in our conventional picture, everything that is now in all 100 billion galaxies that are in our universe, and all the matter and radiation, at some time that we can define where the laws of physics still work, was contained in a region smaller than the size of an atom. I mean, that's unfathomable, but nothing stops it from happening. And there's no force that can ultimately stop that. For certain objects, there are. Gravity is weak enough. And that was, if you saw the movie Oppenheimer, one of the things Oppenheimer was famous for, well, among physicists, was the first realization that if you had a star that was big enough, that even the nuclear forces would not stop it collapsing into what later now we call a black hole. And that was, you know, and so, but there are only special circumstances. The sun, when it stops having fuel, won't be a black hole because the nuclear forces are strong enough to hold the star together, and electromagnetism is hard. But if you have a big enough mass, nothing can beat gravity. Big enough mass, and so.
Yeah, so just the sheer amount of matter, crushing it into
and here, if that didn't make you upset or confused, let me try this. It's even worse, because as the matter gets crushed, it gets hotter and hotter. And actually, in that primordial atom of Lemaitre, or the one I talked about that book, the actual total amount of stuff is far more than the sum of everything we now see, by factors of a million. Namely, almost all of the energy and stuff in that primordial atom has been later dissipated by the expansion, because the universe has done work as it's expanding, and it's lost energy. And so the universe now, with its mere 100 billion galaxies, if you want to add up the total energy of the observed universe in matter, it's a small fraction of the total energy that was contained in that primordial atom. It was so much bigger than you could get rid of all the matter we now see in the universe, and the amount of energy in that region would be almost the same. It's really, the fact that we can even think of those things with a straight face is remarkable to me. And until the 1980s, no one did. I mean, the great change, and I got involved in that, was to think that with some seriousness, we could apply the physics we understand on fundamental scales to explain the universe on larger scales. It's the ultimate chutzpah and arrogance, but physicists are very arrogant, so it's okay.
Okay, well, I had thought, and I think I'm now wrong, I had thought that there was something changed in the laws of physics itself that made it possible, but you're now telling me you literally can crush all the matter.
Yeah, and but when you get to a single point, we know the laws of physics must change, and we know, and people like me, I think most scientists would say it doesn't collapse to a single point, that some new law of understanding gravity will intervene.
It collapsed to the size of a soccer ball.
Or even a soccer ball is amazing, or a baseball, or even a solar system. The densities are unimaginably great, unimaginable.
Yes.
But let me point out that even that, if that may seem so ridiculous that we wouldn't talk about it, or it's not worth thinking about, even the time when the universe was 1 second old, and the universe was somewhat bigger than our solar system, the whole we can actually predict what that weird, incredibly hot, dense system that was 10 billion degrees would be doing with physics we can measure in the laboratory, and we predict the abundance of light elements precisely. One of the things that Jim Peebles won the Nobel Prize for is that we can extrapolate what we can measure in the laboratory and extrapolate back to the universe as 1 second old and make predictions that over 10 orders of magnitude agree with observations. So we know that even that incredibly hot, dense state, which is almost unimaginable, we can test and that our ideas are correct, and they're correct.
It is remarkable.
It is.
You want to change the subject now. You've written in your podcast and things about the politicization of science and the subversion of journals like Nature and Scientific American. Well, talk a bit about that.
Well, look, part of what's driven you and I for much of our careers is the need to have people understand the process of science. It involves two important things. That nothing is sacred. There's nothing that can't be questioned. Okay? There's no such idea that's, and heresy is not heresy. Those are the two characteristics that both you and I find so reprehensible about organized religion, that has led us to try and help people open their minds beyond that. And so it's tragic to me that those two characteristics are infiltrating too much the academia and the scientific community. The idea that there's some things you cannot say, that Richard Dawkins cannot say that there are two sexes, that's heresy, and he should be banned, or he should lose awards for saying something, when in fact the whole point of science and the whole point of education is to make you uncomfortable first, and science only proceeds. I was having this conversation with a friend of mine who's here, who drove me up here. Only proceeds by a dialectic. Whenever I get a letter from people, not scientists, I get letters every day. It used to be letters, now it's emails, telling me that they've been working for 20 years and they have a theory of everything. Okay, you know right away it's suspect, because unfortunately, people have this picture of Einstein working alone, and he wasn't really working alone in a room developing general relativity. Is not the norm. Science proceeds by dialectic. I say something, you challenge it. You criticize me and try and cut to the quick what I'm saying, because that's the way the scientific community works. Because only if I can convince you, only if I can survive the test of experiment and rational debate, will my ideas survive and be worth talking about. So it's essential that there be debate, discussion, and that no idea should be above attack or accepted without evidence. And what we see happening in academia and in the scientific journals is certain things that are not allowed to be said because they may offend some people. And we've always, I know from our discussions, you and I strongly believe that, and our good friends Stephen Fry and Christopher Hitchens said it more beautifully than I can certainly say it, that being offended is, who cares, okay? That science and education should make you uncomfortable, and the idea that people need safety, that scientific environments should be safe.
That is the most contemptible word.
Exactly.
Really, utterly contemptible.
Exactly.
Safe.
What does safe mean? You should...
Not just science, but universities generally.
Yeah, you should never feel comfortable in university. If you are, you're not working and you're not learning.
Yeah.
And so, to me, I've been attacking that idea, but what scares me, and it's more in the United States, but not completely, it's in England too, because I know I was in an Oxford debate on, is everyone religious? Is everyone religious? I took the side of yes, by the way. Some of my atheist colleagues took the other side. And my example was what you might call wokeism, what I call fundamentalist wokeism. That you get rid of religion, and people still believe in certain ideas in the absence of evidence and in spite of evidence, and also defend them almost to the death, that you cannot question them. And this notion of safety, in fact, this young woman was on my side at Oxford, and she talked about safetyism, and which we're seeing everywhere, is the idea that people should have safe spaces in university, is that where they won't have to hear ideas that offend them or upset them. And yet, and I don't know if you have colleagues, but I have many colleagues in the United States who change their curriculum for fear that something they're going to say is going to offend or upset a student, because they know their job is on the line. And that's what's scary, that people can lose their jobs for saying something. In a high school in Canada, I now live in Canada, a woman got fired for talking about, using the word Indian for indigenous people. She was a history teacher referring to the Indian Act of 1918. But referring to the act by its name got her fired, because using that word is so harmful that people will be traumatized by hearing it. I know it upsets you as much as it does me, and it scares me when journals claim it as a fact that science is systemically racist or sexist. I say, show me the evidence. Let me question whether that's the case. And if you question it, that's where you're attacked by these journals.
You can't discuss. If you try to discuss something like that, the mere act of discussing it is taken as that you're partisan in one side or the other.
It's just like Miriam was talking about. It's being a non-believer in Islam. The very fact of asking a question.
Yeah.
If you ask a question about Muhammad, you could be killed, right? And we're not at that stage, but you can be killed academically or scholastically or shamed. And so it scares me when we have the institutions of science defending that non-scientific notion and also claiming to have an end without asking the question. It is true that in the physical sciences, at least, there are more men than women. That's just true. It's also true, by the way, in the biological sciences, there are more women than men. But that isn't discussed, okay? And the presumption that in the physical sciences, it doesn't represent the demographics of the society, the presumption is that that's due to sexism. Or if they're not an equal number of minorities, the presumption is that's due to racism. And you've got to be able to say, hold on, how do you know that? And demonstrate that. And of course, and in all my experience, and I would argue that of all the places in society, academia is probably the place with the least sexism and least racism. And so I'm offended when I hear the head of the National Institutes of Health, who's you may know, I'm Francis Collins.
I know.
Nice guy, yeah, yes. And I know him, and he's a nice guy. He's a friend. I think some of the stuff he says is nonsense, especially with regards to religion. But when he got up and said the NIH is systemically racist, what he should do if he believed that is resign. Stop. If you're saying you headed an institution for 20 years that's systemically racist, how can you really believe that and still be the head of that institution? But they say it because it plays to the crowd. And
I don't understand. It seems to me to be cowardice on the part of the heads of institutions to kowtow to. I don't see what they have to lose, and they're not going to lose their job.
I think now that's an interesting question. Why are they coward? And I absolutely agree with you. The real offenders here are the heads of institutions, university presidents, heads of scientific societies. But you do see what they have to lose, right? Because universities now require university presidents used to be intellectual leaders. Now they're fundraisers, okay? And what they're trying to do, and the way you fundraise is like anything. You advertise, you present yourself as everything people want you to be. And so if you stand, it's just the same as the communist scare in the 1950s in the United States. If you virtue signal, if you say not only we're at the vanguard of anti-racism and anti-sexism, you gain a lot. You gain it sounds good. And if you violate people's rights in the process, what happens? A professor gets fired. Okay, but so if your interest is trying to present a face because you know you're going to be attacked, if you're the university president and you say if you say that not only is your institution not racist, but you think that that it's okay to be offended, you're going to be viscerally attacked by the media and by huge numbers of people online, and what you'll find is there are boycotts. There'll be efforts to get people to stop donating to your university, for students to stop going to your university.
But the people you want to get donations from, billionaires, I just thought rather unlikely to go along with that.
Why would you say that?
Well, maybe I'm wrong.
I will say, I don't know if I should say this in public. No, I've been in communication in an effort to try and think, what can we do to change the situation? One of the possibilities would be to communicate with groups of billionaires who are donating money to universities and say, we won't donate to your university unless there's free speech and open inquiry. And I've actually been in communication with a philanthropic group that represents a lot of these people, and that may be one way to try.
I would have thought so, and it's only my intuition. I don't have evidence for it.
Well, you know, I think what happens is, and I had this discussion with my friend who's here, who's a very intelligent person, but watches this from afar, and the language sounds good. So people say, oh, of course it's good to, diversity, equity, and inclusion are good things. Why are you...
Well, of course that's good, but firing people for...
But they're not aware of that. What they're aware of is the verbiage that makes it sound like they're defending... That's why I changed, I realized, it was a friend of mine, I forget who it was, who convinced me when I was using the word woke as a pejorative, they convinced me I was really not being fair, because being woke is good intentioned. Social justice is well-intentioned. Of course we want society to be just. So the motivation behind social justice is a good one. And so I call it fundamentalist wokeism, in the same way that I guess I say fundamentalist Islam. I mean, I assume there are Islamic people who are just like there are Christians who are kind and gentle and don't believe in stoning and don't believe in this and that. And they're like any religious people. They pick and choose what they like and they don't consider the stuff they don't like. And so you might say that version, those Islams are not, there's nothing inherently evil in that picture, just like there may not be anything inherently evil in many people who call themselves Christian. But fundamentalism is always evil. And fundamentalist wokeism, which is this notion that people need to be removed for heresy, is just as bad whether it's Islam or academia, except in Islam it's people's lives at stake, physical lives at stake. In academia, it's people's careers that are at stake, but it's also science. And if you love science like you and I do, science can only proceed if there are unfettered inquiry. And if we fetter people, then science is going to stop. It happened in the Soviet Union with genetics. You saw it with Lysenko.
There's a terrible book, which is called, a Russian book, which is called The Situation in Biological Science Today, a nice catchy title. And it's a testimony of one geneticist after another confessing to their sins, to their heresies. They stand up one after another and they say, I have offended against the Lysenkoist and against Comrade Stalin, and I denounce Mendel and I denounce Morgan, and then they're led off to jail.
Yeah, and you've seen that there, and in fact, I just in my Substack site published a letter. You often see the scientists, and a number of them are my colleagues. Anna Krylov is a chemist at Southern California. This fellow who just wrote this letter. You see the scientists that are objecting most are often scientists from the former Soviet Union, because they've seen it exactly. When they were young, they had to adhere to the party line in order to be part of the university. Right now, you're aware of this, in university, maybe some of you aren't, in universities in the United States and in Canada, you have to write a statement about diversity, equity, and inclusion in order to get a job, in order to be considered for a faculty position in most universities, or even a postdoctoral position. And the statement can't just be, I'm colorblind, I believe in supporting all people. That's not good enough. You have to show how you are specifically, and have been your entire life, anti-racist. And if you don't, you won't get a job. In Berkeley, where you spent time, the biology department at Berkeley, 2020, the 76% of the applicants were rejected. By the way, their applications for faculty positions are not read first by faculty. They're read first by the diversity and equity and inclusion bureaucrats. And those people removed 76% of the applicants from the application pool that was being considered by the department on the basis of the diversity and equity statements, so you never even got to see whether they were good biologists. Is that scary?
It certainly is. I'm very shocked.
Yeah.
I didn't know it was as bad as that.
It's important, and it's exact. And the people who are speaking out about that are former Soviet scientists, because these statements are basically loyalty oaths. The same as in the 1950s, faculty used to have to do an loyalty oath saying they weren't communists, and if they refused to, they were removed from their positions. And they would even be better if they could say, "I'm not a communist, but he's a communist."
Yes.
And
yes.
you see that here as well, and it's unfortunate.
Yeah. I find myself being blamed for this because many, many times I'm told, well, you got rid of Christianity and this is what we get in exchange.
Well, you know, there's some, you shouldn't be blamed, but that's why I meant all people are religious. And we both realize it. We all want to believe. I mean, we know that there's an evolutionary basis for religion. If there wasn't, it wouldn't be so ubiquitous.
Yeah.
If, you know, whatever it is that holds, whether it's power or societal conformance, there's all sorts of reasons you can see. And Anthony talked about some, why religion has become ubiquitous. So people can naturally want to believe certain things, and this secular religion of fundamentalist wokeism has, for part of the community, replaced it. On the right, there's equal nonsense. It's not just the left. And so I think that we're not to blame for it in any way. It's just we need to recognize that that people are, and people need to realize that the easiest person to fool is yourself, as Richard Feynman said. And that's the hardest thing for any scientist. You and your career and me and my career, I'm sure we've experienced that, where we really wanted to believe something to be right, and probably well beyond the stage at which we should have given up our idea, we kept it because we're human. And being a scientist trains you. By being wrong enough times, it trains you to be suspicious of yourself. And that's really an important part. That's what we should be teaching about science, is to question yourself as much as anyone else.
One of the great virtues of science, the methods of science, especially in medical science, is the double-blind trial, which is specifically aimed at avoiding your self-delusion by this desire to prove your own hypothesis.
And that's why you have to be so much more, that's why I'm so happy I do physics and not biology, right? So I don't have to do double-blind experiments. Well, you do. In CERN now, when looking for because we realize you can put in inherent biases, I was going to say you don't have to probe electrons and ask if you don't have to worry all electrons are the same. But the way it's done now, the Higgs was discovered, is a kind of double-blind experiment. You put in false signals and real signals to see if the experiment can detect between them, because it's so complicated, you don't know. And the people who are doing it don't even know which are the ones.
As they shouldn't.
As
yes.
they shouldn't,
yes.
exactly.
Yeah.
And so that's become the norm in experimental particle physics. But in
Yes.
general, we don't have to worry about the biases of electrons as much as we do about the biases of people.
How long are we supposed to go on for? I haven't been told.
I don't know.
When are we supposed to stop?
What was that?
Is that my
Is that
cue?
your cue?
Ladies and gentlemen, what about that? Hey?
I guess that's our cue. Thank you, Richard. Can I just say, I've been waiting for this moment for many years with you, and it was a pleasure. And I thank you for taking the time to ask the questions and be willing to present them. It's always an honor to be on stage with you, but it was a particular pleasure. Thank you very much.
Yeah, thank you. And I see somebody's bought the cartoon. Is he here? It is. Yes, come and get it. And I've got some. Yeah, a round of applause, definitely. No, the author's not here, I'm afraid. No, I did speak to him. Lovely fellow. Yeah. So this is a bit of provenance. Look, that was how it was originally published back in 1980 somewhere. Fantastic. And so there you go. Bag it up. There's a container for it over there. Yeah. Oh, a presentation. Yes.
No, I bought it. My wife actually bought it as a complete.
Oh. Thank you. I'd just like to say that if any of you want to form a group in the Midlands, and I know that some of you do, just give me an email, president@atheismuk.gmail. What is it? It's .com. Yeah. .com. There's so many. Yeah. But lastly, I know you're all waiting to get down. Well, some of you are waiting to get downstairs and eat. But just before you do, I've got a little book here, which is a wonderful Christmas present for children or grandchildren, called True or False. It stimulates critical thinking in the very young. Don't we need that? and it's written by the VP, the former VP of Atheist Alliance International. Furthermore, he's going to appear on my screen downstairs to write the message that you would like to be stuck into that book for your child. Okay? I will print it, what he writes. You will tell him what to write. I will print it on sticky back. It goes in the book. There it is, a present. Okay? See me downstairs. Thank you very much. And of course, don't forget, our celebrity guests will be signing their own books at the Waterstone store. Go and get them done now.